A student noticed that the leaves on a plant growing close to a wall had two sorts of leaves. The leaves next to the wall were in the shade and looked different from the leaves on the side away from the wall that were exposed to the sun. The length of the internodes on the stem also looked different. The student decided to investigate the differences by measuring some features of 30 leaves and internodes from each side of the plant. Table 1.1 shows the student's results. Question 1. Name a statistical test that can be used to compare the means internode lengths of shaded and exposed leaves. Surely, when we need to compare the means of two groups, we use t-test. Table 1.1 has got the data for different plant features, but we're not interested in all of them. We're interested only in row 1. Carrying out t-test begins with formulating a null hypothesis for the test. Okay? For all t-tests, hypothesis would sound like there is no significant difference between the two means of two groups. Specific to our task, our null hypothesis would sound like this. There is no significant difference between the means of internode lengths of shaded and exposed leaves. Next, carry out the test to find its value. In order to carry out the t-test, you use the formula as you can see on the screen. To use the formula, you need to find the mean values, standard deviation values, and sample size values of both groups. Here, as you can see from the table, mean value for shaded leaves group is 23, whereas for exposed leaves group, mean value is 15. Standard deviation values for shaded leaves group is 4, and for exposed leaves group is 3. You just plug in these numbers into this formula and you calculate the t-test value. So t calculate the value in our example 8.9. Next step is to find the degree of freedom. To find the degree of freedom, you can sum up the sample sizes and subtract it by 2. Or you could take the sample size 1, subtract it by 1, take the sample size 2, subtract it by 1, and sum up their values. So in our example, degree of freedom is 58. Determine the critical t-value at p 0.5 confidence level from the t-distribution table. As usual, when you carry out the test, when you need to find out critical values, you are provided with t-distribution table. And again, for biology class, we use 95 confidence level. 95% confidence level is 0.05 probability level here. So intersection between the 0.05 probability and degree of freedom will give about 2.002. Next step is to compare the calculated t-value with the critical t-value. So our calculated value is 8.9 and critical value we determined from this t-distribution table, which is 2.002. So as you can see, the t-calculated value is greater than the t-critical value. So state and explain the meaning of these results. In order to state and explain the meaning of these results, we need to refer back to our initial null hypothesis. Our null hypothesis was and is there is no significant difference between the two means of internode lengths of shaded and exposed leaves. So you use this null hypothesis and we say, As the calculated t-value is greater than or the critical value, the null hypothesis is rejected. This means that the differences between the internode lengths of shaded and exposed leaves is significant. The difference not due chance and caused by another factor beside of light exposure. If our calculated value would be less than critical value, in that case would surely accept null hypothesis.